of power limitation of the access point, right? Or if your use case demands very low jitters and constant performance in spite of changing number of users, then again, you might lean towards, for that particular use case, using cellular. So in a nutshell, 5G is really built towards enabling a lot of enterprise use cases. It can coexist with Wi-Fi. It will coexist with Wi-Fi, at least in the short term, and we'll see how it goes in the long.
Excellent. Thank you so much. And I want to turn to James now. James, I've got some research hot off the presses I think you'll be interested in. It's interesting to see, obviously, there's a lot of benefits to moving to 5G. The data shows that there's a lot of Canadian companies that are really focused on deploying 5G. In fact, the data that we have showed that 60% of Canadian organizations cited that deploying a private 5G network was their top priority, which I thought was pretty cool. And that's as compared to about 40% in the rest of the world. So significant innovation drivers in the Canadian market. The other interesting piece was, though, from that data, 42% of them said that they lacked the private 5G skill sets to be able to deploy it. So I'm hoping that you can maybe explain how maybe an organization can choose the right connectivity solution for their needs, and perhaps maybe how a telecommunication provider like Rogers can help accelerate that adoption.
That's great to hear that, Bob. And maybe what I'll do is I'll try and knit, just Sarvesh started to weave in sort of the Wi-Fi conversation. And I think Canada's been quite unique. We were very aggressive as carriers and as a country in the deployment of 5G technology. And so, what comes to my mind is that, as consumers and as end users of 5G, had quite a bit of time to actually experience sort of the direct benefit of 5G relative to Wi-Fi. So I think what's happening here is that 5G has captured Canadians' imagination a little bit. We've seen, just take a handheld device as an example, the performance on a Wi-Fi network relative to 5G, it's quite consistent, right? We're seeing throughput now that is of the same order of magnitude, the same megabits per second. Obviously, on a 5G network, you've experienced sort of the benefit of being on a network that has national coverage. You're able to roam and move that experience, beyond the traditional confines of Wi-Fi. So can understand how Canadians are excited about sort of that premise and how private networks and MEC sort of enhance that experience. I think the other thing in Canada, and I think bridging as well, like we tend to be early adopters of technology in the communications domain. Canada does lag in other technology domains, but communications, I think given the scope and breadth of Canada, it's a huge country. We're in many cases separated by thousands of kilometers. So communications is always something that is front and center for decision makers, across Canada from an IT perspective. Of course, there is a constraint in Canada, and I think in many countries, that we just don't have the breadth and depth and number of technology resources for companies to be successful doing it all alone. And I think, again, this is one of the benefits of 5G, say, versus other technologies like Wi-Fi. Deploying a private network in Canada is something that you do in conjunction with a service provider like Rogers. And so when you deploy a network, you're really benefiting from the expertise that a service provider brings to the table across the entire life cycle of the ideation and concept, the engineering and design that spans, not just the spectrum and radio, but also the core network and the integration of that network into the application and sort of cloud domain, and then the ongoing sort of operations and monitoring of that network and resolution of incidents and troubleshooting. So that is, and I can understand, an area where Canadian businesses are concerned, but it's something that from a managed services perspective, it's intrinsically part of a wireless private network deployment. So that really helps enterprises be sort of assured of a successful outcome as it comes to the adoption of these technologies and services.
Yeah, excellent. Thank you so much for that. And one of the terms that's come up a little bit in our conversation here has been MEC, and that's right? The acronym for multi-access edge computing. So I know from prior research that the Enterprise Strategy Group has done that organizations are aggressively deploying applications at the edge. So I'm wondering if we could talk a little bit about the role that multi-access edge computing plays for an enterprise. And Sarvesh, I'm hoping you could get us started this time.
Sure. So as you mentioned, right, the edge computing is not a new concept. Almost all enterprises today have an edge, whether it's an on-prem or in their data center. That's where the data is ingested, processed for value extraction, and then eventually stored. And that processing can involve whether it's transaction fulfillment, local analytics, including video analytics, content caching, amongst other things, right? What multi-access brings it is that it allows facilitation of data ingestion. But what 5G brings to the table with its service-based architecture, it enables an intent-driven traffic steering capability to route that data either locally or to a core data center, right? So this topology decision on where the edge should reside now depends on the need of the application. So instead of having a defined edge that, this is where my edge is, now you can have a hybrid edge as per the needs of your application. For example, if you needed a wide area coverage with low latency, your edge could reside on a telco edge. If you were covering a local area, you still needed low latency, you could now be an on-prem edge. And if you had some flexibility in your latency but required wide area, you could be in a data center or you could be in a telco edge, right? So 5G is really that forcing function that's going to drive this edge evolution. It's going to allow for that seamless extension of the edge from an enterprise edge all the way to the telco edge or even past into data centers or hyperscalers, right? Depending on the need of the application. It will make a service consumption-based topology possible with, local breakouts, which are made easy by the separated out user plane function. So in a nutshell, Bob, it is a new plumbing system with bigger pipes that allows more data to flow at a time, but efficiently and faster. And that is what's going to, and it's already driving customers to innovate, to create technologies to take advantage of that for proper digital transformation of enterprises.
Yeah, no, I think that makes a lot of sense, Sarvesh. I mean, I think when we've looked at it from our research perspective, we see organizations want to get that computing power as close as possible to that customer site. And I think that ability to leverage the telecommunication provider is something that organizations are taking a look at. Our research shows that almost 2/3 of respondents see the strategic value in leveraging telecommunication providers to provide both the connectivity and their distributed locations, right, to host the edge computing environment. So I think that's pretty impressive. And equally, like I said, it's not only just for that distributed edge computing they want, but obviously for the private, LTE or 5G solution. So there's clearly a recognition by enterprise customers that they can leverage the telcos for not only the communication piece, but also as a potential edge computing location, depending on what their needs are. And now, James, clearly what Sarvesh and I just discussed, talked about how an edge computing environment is important. I'm wondering if you can talk about the potential benefits that organizations will recognize leveraging your MEC solutions.
And sometimes it's just best to provide almost a practical example. And I think Sarvesh has done a good job sort of setting up. MEC is really about solving the biggest constraint in cloud computing, which is we know applications and the performance of the cloud can really address the majority of application demands today. The bottleneck or constraint is really in that last mile, connecting whatever device is out in the field, moving that data into the cloud from a computation and analytics standpoint, and then sending that data back to either that device or some type of decision that now needs to be made in the field. And so MEC essentially in that multi-access domain ensures that the network is deterministic in terms of its performance, that we have control and visibility of throughput, that we have control and visibility of the latency, and that those parameters are sort of sustained over the duration of an application session. So that is a little bit of technical jargon, but the best example is really when we start to think now about industrial automation applications and use cases. Imagine a remote user trying to conduct some type of inspection, leveraging robotic vision, a drone as an example. And so we know just in terms of that activity and exercise, that the visual feed, whether that's going to a human operator or going to an AI detection engine, it's got to be high definition, it's got to be consistent, and it's got to be sustained. We can't have variability and variation in the feed of the quality of that video feed. So MEC supports that sustained quality. We've got great imagery coming into the network, coming to that application. So now imagine we've detected some type of anomaly or we're trying to navigate around some type of obstacle. Well, that command and control back to that drone has to be done in very near real time or in real time. So MEC again is about solving for that latency issue, ensuring that that command to move or avoid an obstacle is sent back to that device in real time. And so these applications they're rapidly emerging. Where this is going to become kind of commonplace is really anywhere where we've got robotic vision and vehicle autonomy. And so one of the key and emerging applications for both private networks as well as MEC is really in autonomous vehicles, what we call V2X, which is a vehicle really being able to have visibility and communicate to any obstacles or hazards that it may encounter within the road. And that ultimately, over the long term will be how we get to fully autonomous vehicles on our public roads and highways.
Excellent. No, that's great to hear. And it's interesting to correspond that or dial that in with some of the research that we've done, because it lines up pretty closely as well. When we asked organizations why they were deploying applications at the edge, number one response was we needed to significantly improve a process, right? So how do we collect that data in real time? How do we make sure that we're doing something more efficiently, et cetera? The second most cited was to perform real-time analysis of the data generated there. So a lot of what you were talking about with the autonomous vehicles and so forth, robotics, et cetera, right, really needs that real-time analysis. It doesn't do any good if that they tell you that your vehicle just crashed into a tree 30 seconds after it crashed into it. You would prefer to know the tree is there and avoid it, right? Another couple of things that they highlighted was to reduce the amount of data sent over the network, right? So the comment you were making about latency, I think both of you were making this, right? You can't send enough data over the network, right? If you had to get back to maybe a centralized cloud platform, and that's why it needs to be done at the edge. Organizations were also looking to reduce operational costs, and even some were citing regulations or compliance, right? I need to be able to do that processing on premises. I can't move the data across, right? Especially in like Europe, for example, right? I can't go across my country's borders in order to process the data. So I think there's a lot of value in organizations enabling that multi-access edge computing, being able to leverage the telco sites to host it and have that proximity to where the data is being generated in order to come up with, like you said, the actual, whether that be the use cases around autonomous vehicles, whether it be the video surveillance that could also be used for production as well, right? Quality analysis, quality control for manufacturing. So a lot of great examples there.
Bob, you've touched on sort of two key considerations around cloud, and I think one applicable to both the US and Canada, where huge geographies are what I'll call clouds tend to be concentrated in either the West or East Coast. So in Canada, as an example, the large hyperscalers are concentrated in Toronto and Montreal. You could imagine that introduces, significant latency for workloads that are located in Western Canada, as an example. It's about 10 milliseconds per 1,000 kilometers. So we're talking 40, 50 milliseconds just to get, a packet or a bit of data from one coast to the other. There are alternatives in Western Canada, which is sending data to a hyperscaler node in the Western US. But of course, that in many industries, particularly regulated industries like healthcare and government, that can introduce questions around data sovereignty and data residency. So MEC really is all about putting that compute storage and CPU much closer to where that end customer is, and helping solve not just for latency, but also questions around data residency and data sovereignty.
No, that makes sense. So I think so far we've provided everyone a great foundation on private 5G, on MEC, private wireless network space. But with any new technology, everyone they always really want to know what the use case is, right? What's that killer use case, or maybe in better put, what the use cases are for this environment. So let's dedicate some time to discussing maybe some different industries and how we see this technology fitting in and making sense.
Could I jump in with one important concept? Because I think when we think about private networks, we should frame them in the context of a private network can run on dedicated and private spectrum and radios. They can also run on what I'll call the carrier's sort of common or public spectrum.
Yeah.
And so the private instance of MEC, it's quite intuitive. It's quite obvious. The private WPN instance, it's quite obvious where that is applicable and attractive to many industries. When we think about private WPN, that's where we're deploying radios and spectrum in a location that perhaps does not have wireless coverage today or is underserved. And actually, that's where we're seeing really the earliest adoption of private networks. Locations like mining sites, locations like really industrial manufacturing and processing sites where just one is not availability of public 5G today, just because of remoteness and scale. The second sort of constraint for those types of sites is just Wi-Fi is generally not practical across huge geographies that one might see at an open pit mine or at a massive processing or refinery site. So private networks with private spectrum really fit and are obvious solutions for providing connectivity into those types of applications and sites.
Yep.
Really, the emerging construct around wireless private networks is what we call public WPN, where end customers and businesses benefit from the reach and really the ubiquity of public 5G networks today, but are able to take advantage of that in a way that provides additional security, additional visibility and control that's unique to their organization. And so these are applications now where we're seeing private networks be deployed really in applications like a retail branch or into an office type environment. And I think we'll talk about some of those specific use cases.
Yeah, no, I think that's great, and it's a good distinction to call out for organizations and for everyone listening today. So awesome. So Vesh, why don't we get started, and you can get us kicked off maybe talking about manufacturing.
Yeah, sure. So just talking about smart manufacturing use cases, we can have an hour-long webinar, right? So I'm going to be brief, kind of touch some key use cases and allow us to talk about multiple industries, right? So if you look at smart manufacturing, what MEC and 5G enables are things like advanced predictive maintenance. You can monitor large volumes of data from different sensors, essentially, determining when an asset is likely to fail. And it reduces unplanned and, in fact, in some cases, even planned downtime to as needed versus a fixed schedule, right? That improves the return on assets. You can do asset tracking, again, a broad set of use cases under there, from a simple inventory to actual asset location via 3D maps or modeling in real time, including tracking that asset utilization, reduces asset losses, improves asset value, right? And then autonomous mobile robots. We have today autonomous guided vehicles in a lot of smart manufacturing plants, but they are fixed routes. You can't change them. AMRs can have flexible routes, right? Manned vehicles, obviously subject to higher labor costs, labor shortages, human error, and so on and so forth. So AMR again brings value in that space. Then you have things like precision monitoring and control. You have push to talk, and I'm not going to elaborate on that because it's a well understood use case. The only thing I would add to it is like you can take push to talk and do location tracking with it, chat settings, and so on and so forth, right? So it becomes like an enhanced push to talk, push to video. And last but not least, a whole plethora of use cases that fall under video analytics. You can use them for health and safety. You can use them for quality inspection, and so on and so forth. So as you can see, the list of use case potentially is almost endless, right? So I just touched a brief set so we get a time to talk about other domains too.
Yeah. And James, I know, obviously, I know there's a lot of mining industry in Canada. Maybe you could touch upon on that use case for us?
Absolutely, Bob. Really where we've seen, I'll say, the highest volume and propensity to adopt private networks. It won't come as a surprise. In the mining industry, there's really three key, I'll say, outcomes that technologies help support. One is obviously just safety on a mine site. These are incredibly dangerous places to work and coordinate activities. Number two is really the environmental and sustainability of mine sites, and so that's becoming just a much more critical sort of motivator or outcome for miners. And then finally, it's really just traditional maximizing the yield and output of that mine. And until really the advent of private networks, it's been very difficult across a mine site that can span hundreds of square kilometers, really getting the real-time telemetry in support of all of those three outcomes, and or even just simple communication across that mine site. So what we are seeing as an example, and I'll share some of the early use cases that we're seeing being adopted. Sarvesh alluded to just push to talk, so supporting that sort of health and safety outcome, being able to communicate and talk to anybody that's on that mine site in real time is key. The other really is just the telematics and optimization of material handling. So, I think everyone can picture and imagine, you've got these huge trucks and loaders that are moving materials across the mine. And so ensuring that hey, we've loaded the exact right amount onto the back of one of these trucks. One, it's ensuring that we're not overloading or underloading these trucks. That information can be shared in real time between the loader operator and the truck driver. That's helping drive not just improved productivity, but reducing sort of the maintenance overhead as we're optimally sort of running our machinery and mechanics at the mine site. And so, the great benefit of 5G is that it doesn't have to stop with a single application, that this is an investment that is future-proof for that operator. And so today it's starting with just very basic outcomes and technologies. Over time, as we talked about, technologies like MEC and the benefits of MEC, those miners now will be able to take advantage of, autonomous vehicles as an example. And so those trucks will be able to drive with, the minimal of assistance in a way that's much more automated and efficient across that mine. So it really is a life cycle, if you will, of applications that these private network investments are enabling for these mining operators.
Yeah, I think that's great. There's a lot of, I've heard that also in the agriculture space, right? The automated use of the machinery out in the fields and things like that. So clearly a lot of great use cases. One of the industries that I've been following has been the retail space. And I find that to be intriguing for these private wireless networks and the MEC, because there's kind of a duality to a retail store. There's the front end, right? The public facing, that organization, that the users and customers go to. And then there's the back end warehousing distribution pieces of it as well. So there's multiple ways in which these networks and the edge computing can play a role. When I think about the retail spaces, I start thinking about things like location-based services and real-time offer management, in which that low latency connectivity is really important, right? It doesn't do you any good to tell someone, hey, you interested in, there's a discount on this particular product after they're 50 yards beyond it, right? They're most likely not going to turn around and go back to save 50 cents. But in the time that they're there, maybe they will. I think the other really intriguing aspects of it, in addition to doing those types of things, is also the ability to leverage the additional bandwidth to offer some of those augmented reality, right? We've heard about those digital mirrors where you don't have to try something on. You can just stand in front of the mirror and it'll show you what your clothes look like on you. So there's no need to go to the dressing room and actually try something on. So there's really, leveraging that innovation to try and drive a differentiated customer experience is so important, especially for all those brick and mortar retailers who are trying to compete with the online stores. There's also the ability to do pop-up stores, right? And this goes to more so maybe even the public 5G use cases where organizations want to roll something out quickly for an event. And what we're starting to see more when you think about innovation and technology, a lot of these retailers are building these pods that are completely touchless and unsupervised, right? They're using video analytics to be able to see what people are coming in, taking off the shelf. And then literally, like, you sign in when you're going in, you go in and grab stuff. It uses video analytics to understand who you are, what you've taken, and what you walk out the door with, and it automatically charges your credit card. So some really cool innovation on the retail and the front end. On the back end, in the warehousing, again, some really cool opportunities. I think you had talked about the autonomous vehicles, right? In this case, it's a little bit different, but you hear about these lights out warehouses, especially, right? So critical for these retail spaces that margins are so slim that they're really trying to gain every bit of operational efficiency they can. And so if that means they have robots that can go out the warehouses and automatically queue up all of the products that are needed to be shipped to certain stores at a certain time, then it's really operationally efficient for them to do that. And the 5G enables them to do it and eliminate any blind spots, right? It doesn't do any good if you're, again, if in that low latency again, right? To make sure that all those autonomous vehicles that are in there are operating efficiently, not crashing into each other, not, being able to detect when something spills and go around it, et cetera, those types of things. So I think some really interesting use cases for the retail space. And again, for not only that front end, but also the back end. I think you would talk about asset inventory management, things like that. So being able to track what products are moving as well. I think those are all incredibly important use cases for the retail space, for both leveraging not only the wireless connectivity that 5G can offer, because when you think about it, some of these large retail, wholesale warehouses could be several acres in size, right? So again, from a coverage perspective.
Bob, something we're quite excited about in that retail space, and sometimes the benefits are quite maybe too obvious, if you will. But if you go into a retail store or a retail bank branch, especially a lot of technology that's run on premise to support those applications. So without a doubt, there's a Wi-Fi network, there's traditional LAN that's running, there's on-prem servers. And generally, these retail environments, these branch environments, they don't have on-call or on-staff IT. So when there is a failure or an incident with that technology, you're having to dispatch someone into the field. There's time to do that, and there's cost to do that. One of the huge benefits of a private network is you're able to consolidate a lot of that application infrastructure, a lot of that sort of local LAN infrastructure, and essentially do away with it. And so you're reducing the complexity, you're reducing sort of the non-value add in that branch by essentially running the applications over the top, over the public 5G networks in a way that is secure and meets the application performance needs of that branch and retailer. So some pretty compelling cost benefits in that IT domain by evolving and moving to a private network architecture at the edge.
Yeah, absolutely. So Vesh, you want to talk about maybe the oil and gas industry?
Sure. It's quite similar to the mining use cases that James talked about, right? So, couple of things. First of all, this industry is, high risk, dangerous, tough environment to enable any use case in, right? And worker safety as well as the equipment, right? Failure of any equipment is extremely expensive, right? So things like, asset inspection via video ingestion and analytics, it makes huge amount of sense. For example, drills and other heavy machinery, you can constantly monitor it by cameras. That provides a lot more insights than just provided by on-device sensors that you have today, right? And then you can consolidate that camera view with a lot of information coming in from these sensors, whether it's a minor fault or change in equipment behavior, that allows for faster adjustments so that, you don't have blowouts or accidents and so on and so forth, right? Then asset tracking, which we talked about earlier, in smart manufacturing. Then another key aspect here is an augmented or connected worker, right? Because these guys operate in such a dangerous environment with limited access and room, right? If you have connected devices that can aid these workers who require technical assistance, what that does is it improves the efficiency of the worker and reduces the total number of highly trained professionals who need to be deployed. You can have people in the back office supporting, right? Then you have things like condition-based monitoring to say, hey, look at it in real time, look at the overall picture of all the assets, vibration data, humidity, what have you, and warn of any potential anomalies. Obviously, push-to-talk does come into this place. And another key aspect is the UAVs or drones, right? And those can either be operator controlled, or in cases given the reliability of a 5G network, they can actually be autonomous. They can follow a preset route and monitor and inspect very large sites or large pieces of equipment or very difficult to reach locations, right? And that footage can be analyzed in real time using AI ML because of the high amounts of bandwidth that's provided by 5G and MEC, right? And it can alert the operator of any abnormalities or concerns. So again, these are a few that I've touched on top. And, as you explore the space, there are tons and tons and tons of use cases that can be enabled just by the fact that you have this reliable, low latency, high capacity pipe available with private 5G networks.
Perfect. Yeah, that makes a lot of sense. And James, I'm wondering, I know we've talked several times about the size of Canada today and how it's geographically dispersed. So clearly transportation logistics is something important to Canada being able to do that effectively. Can you share a little bit about how 5G and MEC might enable that industry?
Yeah, I'll touch a little bit on just like how the automotive industry is evolving. And so kind of remarkable, like we understand obviously the potential that, our wireless networks have today. For the most part, automotive manufacturers aren't leveraging or taking advantage of that, ubiquitous and high bandwidth connectivity. Most vehicles have come with SIMs sort of enabled in them for the better part of a decade. Manufacturers have sort of limited the application of those SIMs to downloading firmware to the engine control and sort of the automotive control units. They haven't really looked to leverage that connectivity to improve the overall experience for the consumer in that vehicle, or to improve the overall sort of safety, if you will, of that vehicle. And so what we are starting to see and emerge is manufacturers starting to think of their vehicles really as platforms, having dozens or in some cases hundreds of different applications that are dependent on the network to operate efficiently and to be optimized. And so what we envision, over the next couple of years is that vehicle manufacturers will have a need to leverage technologies like 5G and like MEC to improve both the experience within the vehicle. We're starting to see that already in things like subscription services for entertainment in the vehicle, Wi-Fi hotspots and media subscription services for passengers. But I think more critically over time, the adoption and the acceptance of technologies like self-driving vehicles are going to require, better coordination and connectivity into the network. One, to coordinate, where vehicles are on the road relative to each other, but also to ensure that we can push, regular and frequent updates and firmware updates into these vehicles to ensure that they have the latest, firmware in terms of providing the safest and most efficient experience to that passenger or to that operator of the vehicle. So private networks and MEC, really two enabling and key technologies to facilitate that transformation of the automotive industry.
Excellent. That sounds great. I think that's something that obviously a lot of the consumers are going to be very interested in, and they're going to be looking on. The key point there is all about the customer experience and how do you improve and deliver an enhanced customer experience, leveraging the technology that's available to you today and being able to deliver that to the consumers on a regular basis and a consistent basis. One of the last areas that one of the last industries we'll talk about is the utilities. And I think it's very similar to some of the ones you were talking about with oil and gas as well. But, when we see this, from a grid management perspective and things like that, there's really a strong need to be able to do the real-time monitoring of energy usage, being able to identify where assets have failed. So again, this lends itself to that IoT model, almost goes to the point of when you're thinking about smart cities and things like that, being able to deploy those devices that are able to monitor that energy usage and be able to collect that data in real time so that you can reallocate resources as needed, ramp up, ramp down, what's going on. I think there's also some great opportunities, much like you were talking about for drone inspections, right? Instead of sending workers up to look at a windmill, to look at high tension lines, right, where the power is being distributed, this gives you the opportunity to leverage drones to do that. And not only human control, but as you said, even prescribed routes that are done on a regular basis that are autonomously done, but enabling organizations to be able to manipulate that data in real time and be able to correct any potential issues that they see developing through those inspections. And then clearly, I think there's other things around safety as well, push to talk as well, things like that when people are walking around these the utilities, especially for the high power areas and especially in high tension lines and things like that, being able to identify, having that location-based management, and even some potential fleet management as well. When organizations, certainly when you're thinking about living in the Northeast like I do, there's that propensity for power outages during winter storms. So being able to better track, that's probably a better case of leveraging the public 5G, but an analysis of leveraging the devices that are deployed in the trucks and so forth for organizations to be able to more efficiently route the resources they have to fix the biggest problems that they have as well.
Right. The only thing I would add to that, Bob, is when you say public 5G, as James said, right? Within the public 5G, you can have a private slice for you
Correct.
as an enterprise, right? So you're leveraging the overall public macro network, yet getting the SLA and the capacity and the performance that you need.
Yeah, that's a great point, because no one's going to build a private 5G network across an entire city as a business. But being able to take advantage of the public 5G as a private slice of that is something that organizations will leverage. Yeah, no, that's a great point. So we've covered a lot of ground today, and I hope that everyone's been able to get some value out of these examples. Certainly some great information that's been able to be communicated. I think there's a couple takeaways that I have. The first is that these private 5G platforms are a reality, and there's a lot of different industries that can leverage them to enable that industrial innovation and accelerate digital transformation. I think second, it's possible for remote locations to operate safely and securely while taking advantage of having those apps and services a lot closer to the edge, so they can improve their efficiency, they can improve customer experiences, and they can reduce costs. And third, for me, it sounds like Dell and Rogers have really done the hard work of working together to figure out how to put together an integrated and managed solution that really simplifies the adoption of 5G MEC or private wireless networks in Canada. So I'd like to thank everyone very much for your time. And now we're going to turn over and look at some questions that have been submitted as well. All right, gentlemen. So first question. This all sounds great. So why is the uptake so slow on private 5G networks?
That's a wonderful question, right? What you have to understand is a greenfield versus brownfield scenario, right? We talked about smart manufacturing. We talked about mining. We talked about retail. If it's an existing store, it takes a lot of investment and guts for somebody to say, I'm going to completely revamp all my processes and go ahead and restructure everything and replace things with private 5G, right? That organizational inertia, that comfort that you have with the current state and expertise to say it's working, why mess with it, right? And if I do introduce use cases one at a time, then the ROI is incremental. It's spread out over time, right? So all of those factors make it a little bit of an interesting decision for an enterprise to take. Secondly, as James mentioned a couple of times earlier, right? That disaggregation of ownership. There are so many suppliers because for an outcome to happen, it is not just the MEC. It is not just the connectivity. It's the MEC, the connectivity, the devices, the applications. All of that has to be integrated end to end. And those have to be integrated into the existing IT OT systems that enterprises have, right? And it's pretty much of a heavy lift. And there's no single system integrator can take ownership of the whole thing. We require system integrators that can do the infrastructure stack. You need SIs that can do the application part of it. And you need SIs that can be that prime solution integrator. And then last but not least, service assurance, right? These enterprises are not yet used to kind of leveraging what the CSPs have to offer in terms of giving them full service assurance. So that is one aspect that they're uncomfortable with, to say, hey, who do I call for performance? Who do I call for troubleshooting? If my application's not working, is it the application's fault? Is it the underlying infrastructure's fault? Is it the fault of the connectivity platform? I don't know. So these are the things that kind of slow down, because enterprises then take a pause and say, how am I going to make this happen? I think this is where partnerships like Dell and Rogers together, where Dell says, don't worry, guys, we'll be the prime integrator. We have extensive experience with the stack at the infrastructure level, with the stack at the application level. We have an extensive SI partner base. We can help you by being that prime integrator. And with Rogers coming in to say, look, we have extensive experience with giving service assurance, right? We can manage this service for you. But last but not least, ROI. We will have to figure out consumption-based costing, right? Because these use cases are incremental and enterprises are averse to kind of putting a lot of money up front to then extract value over time. So these are some of the hurdles that we have to cross as an industry to really kickstart the adopting of private 5G and MEC networks.
So really great stuff there. James, I got one question here about environmental sustainability with these solutions. Could you maybe touch upon what Rogers is doing to help companies improve the environmental sustainability?
Yeah, absolutely. Thanks for the question. I think, again, it comes back to sort of industries and use cases. So there, of course, are a couple of developments that are really pushing ESG and sustainability to the top of many organizations' priority. We've seen governments in both the US and Canada really solidify what I'll say incentives for businesses to become more sustainable and more green in terms of their energy consumption. And so an area where we are actively sort of investing and developing use cases is in the segment that we call connected spaces. And this is really about helping property owners, property managers really run their buildings more efficiently with a focus on, one, really the sustainability and ESG sort of outcomes of their building, two, to deliver great digital and guest experiences for their tenants as well. And so when we think about wireless private networks and MEC, it's really about unifying a lot of the systems that are in a building today. So the majority of what I'll call kind of Class A commercial real estate, we've got sort of smart lighting where we can control and regulate lights and energy across that building, but we haven't married that with really the intelligence of the network and with the cloud. And so what technologies like private networks allow us to do is to aggregate occupancy data, aggregate building data, and integrate all of these systems together in order to optimize what areas of a building are being heated or being lit based on the occupancy and based on time of day. So that's really where, again, just the marriage of network, compute, and data are helping drive these types of outcomes.
Excellent. That's great. Well, folks, that's all the time that we have today. So I want to thank you very much to my guests who joined me today and to you, our audience, for joining us. We hope you found this discussion valuable as you're looking to transform your organizations and evaluate your own 5G, MEC, and private wireless network projects. Make sure to check out the attachment section of this webinar for additional resources, and please do leave your feedback when prompted. Thanks very much.